Calculus 2 for engineering students, lesson 2. In this lesson, we are going to work on inverse hyperbolic functions. In lesson 1, we defined sin hx as ex minus e minus x divided by 2, cosine hx as e to the power of x plus e to the power of minus x divided by 2, and tan hx as sin hx divided by cosine hx. We saw the graph of y equals sin hx as similar to this graph. It's always increasing. It's 1 to 1 on R. Graph of cosine hx is an even function. It has a line of symmetry. Y-axis is the line of symmetry. It is not 1 to 1 unless we put some restrictions on its domain. For example, if we say x is greater or equal than 0, then the function is going to be 1 on 1. That means the function is 1 to 1 by assuming x is greater or equal than 0. It's not the only restriction that makes the function 1 to 1. Graph of tangent hyperbolic of x, it's always increasing. It's 1 to 1 on R. Therefore, when x is a real number, y equals sin hx and y equals tan hx are invertible, and when x is greater or equal than 0, cosine h inverse of x is invertible. Let's quickly sketch the graph of the inverse functions. We have to draw y equals x and then mirror image about y equals x. This would be the graph of cosine h inverse of x when x is greater than 0 on the original function. That means in cosine h inverse of x, x is greater or equal than 1 and y is greater or equal than 0. The graph of sine hyperbolic inverse of x, its domain is all real numbers and range is all real numbers, and the graph of tan hyperbolic inverse of x is something similar to this graph. It has two vertical asymptotes. Since the range of the original function is between 1 and negative 1, the domain of the inverse is between 1 and negative 1, and the graph would be something similar to this. It has two vertical asymptotes, and x is between 1 and negative 1, and the range of the function is all real numbers. Let's find the equation of the inverse function for y equals sin hx. Let's assume the inverse is sin h inverse of x is y. This means x is sin h of y by definition of inverse function. That means x is e to the power of y minus e to the power of minus y over 2. If we times it by e to the power of y and divided by e to the power of y, we have x equals e to the power of 2y minus 1 divided by 2e to the power of y, which is the same as e to the power of 2y minus 2x e to the power of y minus 1 equals 0. This is a quadratic equation. If we solve it, e to the power of y would be x plus square root of x2 plus 1, or minus using quadratic formula. Since x is always smaller than the square root of x2 plus 1, x minus square root of x2 plus 1 is negative. Therefore, x minus square root of x2 plus 1 is inadmissible. This means e to the power of y is x plus square root of x2 plus 1. Therefore, y is line of x plus square root of x2 plus 1. Other words, sine hyperbolic inverse of x is line of x plus square root of x2 plus 1 when x is a real number. By repeating the same process, we'll see cosine hyperbolic inverse of x is line of x plus square minus 1 when x is greater or equal than 1. And tangent hyperbolic inverse of x is 1 over 2 line of 1 plus x over 1 minus x when x is between 1 and negative 1. Let's find the derivative of sine h inverse of x. Derivative of sine h inverse of x and derivative of line of x plus square root of x2 plus 1 are the same. We know if u is a function of x, derivative of line of u is u prime over u. Therefore, this derivative is derivative of x plus square root of x2 plus 1, which is 1 plus x over square root of x2 plus 1 over x plus x2 plus 1. This is u prime over u. By taking the common denominator on the numerator and simplifying this, we'll see the derivative of sine hyperbolic inverse of x is 1 over square root of x2 plus 1. Since cosine h inverse of x is a line of x plus square root of x2 minus 1, we can use the same method and find the derivative of cosine hyperbolic inverse of x, which is 1 over square root of x2 minus 1. Derivative of tangent hyperbolic inverse of x is 1 over square root of x2 minus 1 when x is between 1 and negative 1. By finding cosecant h inverse of x as a function of line and taking the derivative, we can find the derivative of cosecant h inverse of x and see it is negative 1 over square root of 1 over absolute value of x square root of x2 plus 1 when x is a real number. Derivative of secant hyperbolic inverse of x is negative 1 over x square root of 1 minus x2, and derivative of cotangent hyperbolic inverse of x is 1 over 1 minus x2, and in this case x is either more than 1 or smaller than negative 1. By applying the chain rule, we can see the derivative of sine h inverse of u when u is a function of x is u prime over square root of 1 plus u2. If instead of x we put u, we have to times the derivative by u prime, and instead of x put u. Derivative of cosine hyperbolic inverse of u is u prime over square root of u2 minus 1. Chain rule again. And derivative of tangent hyperbolic inverse of u is u prime over 1 minus u2. 1 over 1 minus x2 becomes 1 over 1 minus u2, and we times it by u prime. Similarly, we can find the derivative of, for example, secant h inverse of u, and it is minus u prime over u square root of 1 minus u2. Thanks for watching.